Okie dokie, I'm going to go ahead and get started. Okay, so last week, of course, we covered sort of how to generate our markdown documents and how to do some very basic stuff in R. So that's a pretty cool feature. It's something I'm going to be using for the rest of the term, and I hope you find useful enough to use for sort of classes and your own work in the future. We're going to jump next into similar fun, useful, and interesting stuff. Well, a lot of programming courses might spend a huge amount of time dwelling on sort of the structures of data and basic ways to do programming. I like to start with the fun stuff first and then fill in the gaps afterwards. So today we're going to open up with visualization with plotting with GGplot 2, which is sort of the dominant platform for doing graphics in R for most analyses and things. Before I get into that, though, I want to cover a few other little useful things you may have noticed me doing or things that might be lingering questions for people. So first of all, you've probably noticed sometimes in the code, like in the slides that I have, or maybe in other people's code, that there'll be code that looks something like this sometimes. So I'll have some kind of R code I'm running over here, but then just a bunch of text over on the right. The pound sign or hash symbol here is known as the commenting symbol in R. If you write some sort of code anywhere in an R script or in a chunk in an R Markdown document, anything you write after that pound sign will not be run as R code. This is how you write notes to yourself or notes to other people in your code. So I recommend, especially as you're getting started early, write lots of comments, like write lots of notes to yourself, right? So the worst enemy of present you is you who wrote code about a year ago, because you will have no idea what that person did unless you write good notes and comments in your scripts. With big projects, I like to start my big projects with about a paragraph of comments at the top that frame the entire problem the script is meant to tackle, what I'm going to do, maybe like, what was the purpose of this, what project it was attached to, so I can start at the top and be like, okay, put myself back in that mindset. And then throughout the scripts, I'll have little comments about things. For the most part in this class, I'm going to try and teach you how to use coding methods that will be obvious what they are doing at every step, so comments will be less necessary. But if you're ever not sure that you will remember, by which I mean pretty much all the time right now, not sure what you'll remember what some code does, just write a little comment next to it and say, oh, this does this, this does that. Writing that comment also will make you remember whatever that code was better later. It's like writing notes down in class. Even if you never look at them again, you'll remember it better because you took it in two different ways. Okay. If you write a hash symbol like that and then write text in the body of your Markdown document, do you guys remember what happens? It's not a comment. It makes a big header. This comments up here, that's big text like that, is what happens in a Markdown document outside of a chunk if I write that hash symbol and text after it. It makes a really big header. So you can't use comments inside the body of a Markdown document, just inside of chunks. Okay, so if you want to save objects in R, you can save any object you create in R, which includes functions, whole data sets, things like that. You can save them just using the save command like this, like save new.object that I created before, file equals whatever you want to name it. If you do r.rdata, it saves it as an rdata file, which is R's default storage format for objects. If you want to open up a file, you can open it with load and then whatever is the name of that object. You'll probably ask yourself immediately, well, if I do that or that, where are these files being saved and loaded from just by default? Okay? R uses something that is called a working directory. Python has something similar too. So R will save files and look for files you want to open in your current working directory. If you want to know what your current working directory is in your R console or in the script, you can just type get wd, and it will tell you the current working directory that you have that R is running in. In the case of when these lecture slides were run last, which was late last night, my current working directory was my OneDrive where I keep my GitHub files, this class, my lectures, and my week 2 lecture. Wherever you currently have R open to is probably going to have a different working directory. I would assume you don't have a working directory on my computer, so probably a different one. Yeah. You can set a new working directory just by doing setwd and giving it some sort of path. I'll note that you do not want to set working directories in R Markdown documents. R Markdown documents automatically set the directory the file is currently in, the .rmd file is in, as your working directory. If you move an RMD file to a new folder, when you reopen it, that will be the new working directory. This means that if you want to access files and things related to this our Markdown document, if you put them in other folders or in the same folder as that, you can move the entire folder around, and as long as you reference relative to that current directory, you'll always be able to access files attached to that R Markdown. That's somewhat complex. If you want to mess with that, let me know in lab, and I'll show you about sort of organizing directories and things like that. Okay, so managing files. When you're managing R projects, in my opinion, it's normally best to give every single project, and in this class, each homework is sort of its own project, every project its own folder. The system I use for organization, which you're no way required to use, come up with your own method, but this is what I use as an idea. Every class or project has its own folder. Every assignment or task within that project has another folder inside of that, and that is the working directory for the particular item associated with that, which is why I have like a lecture 2 directory in a my lectures directory, in my CSSS508 directory, in my GitHub directory, so on and so forth. My .rmd and .r files are named as clearly and completely as possible. So for instance, I have a whole structure that looks like this. Anything I'm going to upload into my GitHub is on a dedicated area. Don't worry if you don't know what GitHub is in Git. Maybe I'll teach a class on that in the future. CSSS508 is this class. Lectures is what I give to you guys once a week. This is week 2. And then notice here, I don't just say like lecture.rmd. I actually name the entire file CSSS508 week 2 GGplot 2. This is redundant information. But for me, this is really nice because it means if I want to go directly to that file, I can run a file search on my computer for like GGplot2, it will get that. I can search for week 2 RMD, it will get that, right? It's just useful. I can find it wherever I want. If that file is somehow isolated, I know exactly where it goes, the whole structure to it. Okay. So, use whatever system you want, but the main thing is I would recommend being very consistent so your projects are organized. If you want to take it to a slight extreme, you could actually have functions like I do on my computer that make it so every time I start a new R project, it generates the exact same hierarchy of folders between all of them. So no matter what project I'm in, they all have the same like syntax folder, the same functions folder, the same image folder, the same tabular output folder, all that. Every project looks identical. It means I can use the same functions to operate all of my projects. Okay. Another thing, yeah, be consistent, use detailed names. You don't want to lose work by overwriting files or by naming them all things like file1 or test1. You'll tend to overwrite things and you'll have no idea what they mean if you look at them. Your file name should be clear enough that you look directly at it without opening the file and you know exactly what that file is for, in my opinion. Okay. If you have large projects that have lots of files, and I actually do this for every single project I have, I recommend RStudio's built-in project management system. It's in the top right in RStudio. They have a little like project thing. You can create projects. What that does is you open each project and it opens its own entire RStudio instance for that project. All the files you open and run in it are contained within it, and it manages the working directory for every script file you open in that particular project. It's a nice little unified environment. Lets me quickly jump between projects. So today I was jumping between about 4 or 5 different R projects associated with different research projects, this class and things like that. I can just click a project, it closes all those scripts, saves everything going on, opens the next one, and returns me to where all of those files were open the last time I used that project. So I can just jump back and forth. I'm never opening or closing scripts if I don't want to. It's great if you have like 30 or 40 scripts associated with some really large sprawling project. Okay. Okay. Some additional plugs. If you're working with journal articles, and by journal articles I mean broadly anything you're probably going to send out for publication, so it needs to be nicely formatted and well done. There's a package by Ben Marwick in Archaeology called RR Tools that I really recommend. It sort of forces you to set your projects up in this unified way so that you can produce like whole dynamic documents of journal articles formatted nicely as PDFs using the book down package. Browse around on there. It's a pretty cool package that sort of manages all the project management stuff you need for journal articles. He also has a package called Husky Down that is for UW dissertations and theses and automatically formats them using the LaTeX template the university provides to make your dissertation and thesis look like it's a official UW one without you having to know any of that LaTeX stuff. is pretty handy. Just use Markdown. You can do the entire thesis or dissertation. It's great. If you're interested in our R tools, I actually have a demo presentation for it on my GitHub. I think there's even a video lecture attached to it. It's kind of cool. Check it out. Okay. File types in this class. So I kind of briskly went through file types in the first lecture, and I want to go back over it because this stuff is really important. So in this particular class, we mainly work with 3 types of file. We work with .rmd files. These are your markdown syntax files, the things you're opening and working in to turn in homeworks in this class. RMD files are where you write code mixed with text for the purpose of making some output document. In this class, homework assignments. In other cases, they might be journal articles, a dissertation, an entire book, a website, or presentations. The presentations you're looking at right now are all in the .rmd file. You can do a lot of different things with them, but they're generally just R markdown format. Next, there are .r files. R files are R syntax files. This is where you write code for processing and analyzing data when you don't intend to make an output document directly. You can write code into a .r file and run it using a .rmd. You can load it using a function called source, which I mentioned down here if you're interested in it. So if you have like 500 lines of code you need to process for some RMD file that's going to generate an article, you can do that outside and not put it all in the RMD file by calling on source. That's how I do dynamic journal articles that like update their data and things like that. The RMD has very little code in it because it opens an R script file in the background. In this class, I don't focus much on using our script files because our script files work exactly like the inside of a markdown chunk. Nothing special about them. Markdown's a little trickier, so we focus on that in this class. Lastly, there are HTML or PDF documents. In this class, mostly HTML. These are the output documents created when you knit that .rmd file. These are the output. That is the input. Okay? When you turn in your homework, you turn in the first thing, and you turn in the third thing right there.
Why do you like HTML instead of the PDF?
So people don't have to mess with a tech distribution on their computer. So people on Macs need Mac Tech or Tiny Tech. People on PCs need Mic Tech or Tiny Tech. Those can cause problems for people sometimes. Another nice thing is that if you're rendering larger homeworks later in the class, sometimes they take a while to render, and PDFs take about, on average, about 8 to maybe 20 times the system time to actually render. It doesn't look like it, but they take a lot longer to render. Some things they take way longer to render. HTML is the fastest rendering format for RMD files. I like that. Plus, they're a little easier to share because you can just send somebody a web page. They open up quickly. And they display nicely in Canvas, so people don't have to open them up when they're doing peer grading, as you'll see in a bit. So, my preference. But if I was going to hand in a homework assignment, obviously a journal article or something, I'd always do a PDF document. Sometimes a Word document. You can do whatever you want. It's pretty easy to swap between them. HTML is the least finicky. Great question. Okay. It's important that you understand the difference between these files. Ask now if you need a clarification about any of this. Also, if you don't feel like asking in class, feel free to get me afterwards or in the Slack channel or on email. Pretty available, easy to get. Okay, now we can actually go on to our GGplot 2 unit. So, we're going to work with the Gapminder data today. That's actually my favorite image if you're into RStudio memes. Yes. Anyway, the Gapminder data we're going to be working with today is from Hans Rosling's Gapminder project. It's a panel data set that's really useful for doing all sorts of visualization stuff. We can access these data through an R package called Gapminder, which has been cleaned and assembled by Jenny Bryan at UBC. This class is, at this point, slightly based on Jenny Bryan's version of this class at UBC. Anyway, to install this package, in the console, not in a markdown document, not in your script file, just in the console, do install.packages, in quotes, Gapminder, and then you can load the package with library Gapminder, and that'll load up the data. Okay, so let's check out these data. So, if we load the Gapminder data, you'll get this data frame in your environment called Gapminder. All right? This is the structure of it. So if you remember from the first lecture, there's a function, str for structure, that will show you the structure of whatever object you give to it. It does different things depending on the type of object you give it. In this case, we've given it a data frame. Okay, what we see here, the first thing is the object we've given it, which is Gapminder, its class is a data frame. It's also a tibble and a tibble data frame. Those are special objects that are generated by DeepLiar, a package we're going to start talking about today, and related packages. It has 1,704 observations, so it's moderate size. It's not a tiny data set. It has 6 variables. The variables are country, continent, year, life expectancy, population, and gross domestic product per capita. So these are the types of variables over here. We see these first ones, country and continent, are something called factors I haven't really talked about yet. I will in a second. These are, this is an integer, year, this is something numeric, this is an integer, this is numeric. So these contain number information, these contain categorical data. Okay, so first interesting thing, like I just said, is that there are factor variables, which are country and continent. Factors are a type of data in R that represents something categorical, something like text, but they have an underlying numeric representation. We're going to spend a lot of time on factors later in the class, but the gist of it is that factors are useful if you're fitting models with nominal data of some kind, because factors are how you control things like reference levels in a regression with dummy variables. Also the ordering of factor levels will control the order in which things are plotted in GGplot today, as we'll see. Okay, so this data set has a lot of observations, enough that you're not going to want to display the whole data frame like on your screen at once. 1,704 isn't considered big data by today's standards, but it's enough that you can't look at it all at once. Next, these data have a nested or hierarchical structure. So there are years for each country, and each country is in a continent. So in statistical or in data terms, these are a type of panel data, where each country has multiple observations. Okay? Okay. So if we want to do any kind of visualization with data, we're probably going to want to be able to grab individual chunks of data and do something with something other than the entire data set at once. So we need to subset our data. So to be able to subset our data, we want to sort of slice this data frame up into individual chunks. That is, say, in this case, maybe we want to select only the rows associated with the country of Afghanistan, or maybe only the rows associated with the year 1997. There's base R ways to do this. I don't like them. They're kind of out of date compared to what is sort of the standards in R. We're going to use what is the industry standard sort of package for doing this, something called DeepLiar. The DeepLiar package is part of the tidyverse family of R packages that are the focus of this class. Pretty much all the stuff I'm teaching you that's a package of any kind, most of the functions we use in this class are in a package inside of the tidyverse family of packages. These are sort of the dominant way of interacting with data in the R environment. Okay, so if you want to install the tidyverse, I'm going to give a warning before you go ahead and do this. If you want to install the tidyverse, you just do install.packages and then in quotes tidyverse. My warning is that this is going to install a very large number of packages. We're going to use a lot of them in this term, so this is a quick way to get all of them in, but if you start running it now, it might take a while. And by a while, I mean it usually takes less than 5 minutes, but with everybody doing it simultaneously, who knows what's going to happen. But yeah, just as a heads up. You could also install the individual packages we're going to be using today, which are DeepLiar and GGplot2, and then save that for later if you want. Feel free to go ahead and do either one, though. Anyway, DeepLiar is a very, very useful, very powerful package. The package of it has the functions I use the most on a day-to-day basis of anything in R. We're going to talk about it a little bit today, but we're mostly just going to use it for filtering data. Next week, we're going to spend the entire lecture on using DeepLiar for just about everything. Okay, so if you have the tidyverse installed or just DeepLiar, you can load DeepLiar and not every one of those packages with library DeepLiar. When you do that, you're probably going to see something like this pop up. Attaching package DeepLiar, these objects are masked, these ones are masked from that. So if you've never seen that before, you're probably going to think to yourself, oh, is that an error? Did I mess something up? The answer is no, you did not. It's just that DeepLiar is kindly informing you of something very important. So if you load a package in R that has some functions in it with the same names as functions in other R packages, it overwrites them. This is called masking. This message is just letting you know that it has masked some functions that exist in other packages you already have loaded. In our case, by default, when you turn on R, when you open it up, the stats package and the base package load as soon as you turn on R without you specifying anything. What this is saying is DeepLiar has overridden the filter function and the lag function in stats and overridden intersect, set diff, set equal, and union in the base package. These things that it's replaced, for the most part, are ones that function almost exactly the same but work a little bit better. That's about it. It just lets you know when it happens. If you have other packages loaded, there might be a lot more things masked off. Pay attention to it. Sometimes you'll have your code behave in a very strange way because you have some function you're using in your code and you don't realize that you have two different packages with the same named function. You load one of them like later, it overwrites that function, you try and rerun the code, it behaves totally differently. The most common instance of this is the mass package, MASS, all caps. That's a package really commonly used because it has the negative binomial function, like the normal negative binomial function for R for regressions. Well, it has a function called select in it too. DeepLiar has a select function you use constantly. You want to load the mass package first, then load DeepLiar, or put it in a different position in the environment. I talk about that later in the term. Just know that if suddenly a function behaves differently than it usually does, that's what's probably going on. Okay. If you want to hide warning messages like these when you load your package, just put them in a chunk that has messages equals false or include equals false, and it will hide that output. That way you don't have at the top of your markdown document this big list of all the things that got masked off. Okay. Another type of warning message you'll commonly get when loading a package is something like this. You'll load a package, and then it will say something like, Gapminder was built under R version 3.4.1. About 90% of the time, that message is saying your version of R is out of date, because this would normally be something where it would say, this was built under 3.4.1 because you have 3.4.0. This is R's way of gently reminding you to keep your software up to date. If you want to get rid of that message, just update your R, it will go away. If it was built under an older version of R, this error message would not pop up. Okay, so DeepLiar has something in it called a Magritter operator. DeepLiar lets us use these Magritte operators, otherwise, and probably from hereafter known as pipes, to pipe data between functions. This is what I was talking about a lot in lab and a little bit in lecture last week, that nesting functions inside of each other eventually gets to be really hard to figure out what's going on. So instead of putting functions inside of each other like this, we can actually make them go left to right, reading like most of us would read text. So let's say if what I wanted to get was the population in the Gapminder data, so like the vector of all the populations. I wanted to get the mean of this variable, but then I wanted to get the log of the mean of population. This is the base R way of doing that. It goes inside to outside. So I have the variable I want, then I take the mean of it, then I take the log of it, right? Most of us probably don't like instinctually read inside out from pretty much anything, right? If we want to instead pipe this around, we can do it like this once DeepLiar is loaded. I could say Gapminder pop, this pipe operator, mean, this pipe operator log. You'll notice I get the exact same value. So the way to read this is, let's take Gapminder population, let's send it to the mean function, then send the output of the mean function into the log function. Pipes read left to right, so it allows you to chain functions together, an infinitely long chain of functions. I have scripts, which I'll probably show in week 10 or something like that, that might have 75, 100 plus function calls all chained together. And you'll notice here, I didn't create any intervening objects to do this. I have scripts that process entire data sets all the way through to the analyses output of plots without ever creating an object, right? Because you can just chain from one thing to another and go all the way down for as long as you want. And you just read them top to bottom. You could put each one of these commands on its own line and just be like, oh, it does this, then it does this, then it does this, then it does this. It's a much more intuitive way to write code than to nest all your functions inside of each other.
But it'll go either way. You can run it both ways, obviously.
In like both of these?
You can do it that way. And
it's exactly equivalent.
It doesn't matter which package you have, it'll do it.
for
the top one, but then with the DeepLiar, you need that one.
yeah, you need DeepLiar. The reason you need DeepLiar is just because DeepLiar contains the pipe operator. Yeah, there's also the pipe operator actually originally comes from a package called Magrider, but DeepLiar loads that for you. Yeah, it's just because of the pipe operator that we need. It's actually fairly complex to program this pipe operator, which is why we need a package for it and why it's not a base R thing. But yeah, that's all you need DeepLiar for. Otherwise, these functions and everything are exactly the same. Yeah?
If I wanted to round that to only 2 decimal points, as you have recommended in the homework, could I tack a command onto there?
Yeah, just pipe it into round, and just to pipe it into round with 2 in round. So the way the pipe actually works, which I'm going to get into next week, is whatever is on the left side of the pipe becomes the first argument of the function on its right side. So this would just, Gapminder pop goes as the first argument to mean. Most of the time we only give mean 1 argument. We usually only give log 1 argument. Round is an example of something we usually give 2 arguments to. We give it something we want to round and the number of digits we want to round it to. In that case, you would pipe it to round, but the first argument is already taken care of by log, so you just type 2 into round. It would know the first argument is coming out of log, so it would interpret the 2 inside of round as the second argument of it. It's okay if that's confusing. We're going to spend the entire term piping things, so you'll get some experience with it throughout this lecture and also the rest of the term. It starts out being real confusing, and then very quickly you'll be like, why would anyone do this any other way? The answer is most people don't do it almost any other way if they can avoid it. Okay. An example of a common operation we want to do with just about any data is we want to subset it to particular rows. Here's an example of a DeepLiar way to subset rows. I'm taking the Gapminder data, I'm piping it into this command filter. That was the one that overwrote the filter command in the base stats package. And I just say country equals Oman. We see what happened here, don't we? For the country column, every single one of the rows that remains is Oman. Okay? This is how you subset things in DeepLiar. Probably going to ask, well, what exactly is going on up in here? Okay. What we're performing inside of the filter command is something called a logical operation or a logical expression. What we use right here, the double equal sign Oman, is for testing equality of things. We said country equals Oman. What this does is if you actually saw the output of just country equals Oman on this data frame, it's going to be a big series of trues and falses. Anytime country is exactly equal to the word Oman, it would return a true. Anytime it is not equal to Oman, it would return a false. All DeepLiar is doing with the filter command is returning the rows that have a true associated with them and getting rid of the ones with a false. So if we imagine what filter is really doing, so we have a country column, and then we can imagine that it's creating a new column just for a second to do a check that I'm going to call the filter column. If this is Oman, this is USA, this is Barbados, and then this is Oman. Okay? What the filter equals Oman is doing is it's just going down line by line and saying, oh, that's equal to Oman, put a true here. That is not, that is not, that is a true. Then it just dumps all the ones that encounter a false and returns all the true rows. That is filtering. Filtering is how you select rows. Does that make sense to everybody?
So it doesn't drop anything either. It's just like for that subset.
So what it does is it doesn't modify the original object in any way unless you overwrite the previous object. This is something universal across R, is that you only actually modify an object if you overwrite it. If I wanted to permanently modify Gapminder so it was only the Oman countries, I would do Gapminder assignment operator and then this line of code, and it would overwrite it. Okay. Okay. There's all sorts of other logical operators that we can use to get things done. So there is a not equal to, so instead of equals, you do bang equals or exclamation point equals. There are greater than, equal to, less than or equal to for numeric comparisons. There is %in, which is used for checking equalities against multiple things at the same time. This is equivalent to saying equals something or something else inclusively. I'll use it in a minute to clarify that. We can also combine multiple logical conditions at the same time. And requires 2 conditions to hold at once, or more if you keep adding more ands. Or means 1 condition needs to hold, and it's either condition. If both conditions hold, it still returns a true. It's not an exclusive or. And then exclamation point or bang, if you're an old school programmer, inverts a logical condition. So if you put exclamation point in front of another logical condition, it will just flip all the trues to false and all the falses to true. So sometimes you can think of a way to select something, but you want the opposite of that. You can use that to flip to the opposite. Some things are really easy to figure a positive like selection or a negative selection, but not the other way around. So just write the one you can think of and reverse it if you need to. We'll experiment with this some. Okay. We're going to use most of these repeatedly throughout the class. Don't have to worry about memorizing them. It'll become intuitive as you use them. You can always refer back to this or do like question mark back tick like pipe or something like this, or one of these back tick, and it will open the help for all the logical operators. You actually see there's a bunch more logical operators too. Okay, so let's talk about using multiple conditions at once. Let's say we want something like all the observations from Oman, but only those that are after the year 1980 up to and including the year 2000. It's pretty easy. We just say Gapminder, pipe it into filter, country equals Oman, and year greater than 1980, and year less than or equal to 2000, and it just does it. So you can just chain together logical conditions inside a filter. What do we get? The 4 observations that are of Oman after 1980 and before the year 2000. Doesn't affect the columns in any way. We get every single one of the columns that were there originally. Does that make sense? Any questions? Yeah. This is important. That's a great question. So the thing about R is that R runs commands line by line, but what R thinks of as a line is not necessarily the same thing as us. So anytime you end a line with an operator being the pipe sign, an and sign, or a comma, it will continue running the same line of code on the next line of text. This does not end with an operator. This ends with a close parenthesis, which is the end of a function call. When it encounters that, it's going to run everything from the start of that line, what it sees as a line, to the end of here. If I then add another line of code under it, it's a separate command. Does that make sense? I can play with it in the console if people are interested. Yeah. We could, however, let's say we wanted to run all this filter but then do something else with the exact same data. Instead of writing this to an object or anything, I could just add another pipe here. Then it would continue reading the code on the next line, doing the exact same, like the operation. So I could do filter, and then I could say, I could pipe it into some sort of summarize, aggregate function, or even a plotting function, which we're going to do a little bit later in the lecture. You kind of get an intuitive feel for this as you mess with it. It's okay if it's just right now. Perfectly fine. I was saying to somebody after the lecture on Wednesday, this class is basically like a fire hose. If you stand in front of it with your mouth open, you're just going to drown. Take little sips. It's okay if things are like overwhelming at times. Refer back to things, ask lots of questions. It's impossible to like cram 100% of the lecture material in one go. Instead, I'm just like hosing everybody down with information. You get a little bit of it and you return back to it later. Yeah. Which is not the format of a lot of college classes, so, get used to it. It is with stats classes, though. They just destroy you. Yeah. Okay. So, we might want to save some subset of data if we're going to use it repeatedly. That way we don't have to keep doing all those chain together pipe commands over and over again. So if we think there's some subset of data that we're going to keep using over and over again, we can just save it like any other object we would in R. It looks like this. In this case, I'm going to filter down just to the observations that are from China, and I'm going to save it to an object called China. So I just say China, assignment operator, Gapminder, type it into filter. And this is the interesting thing about this. You notice that we have the assignment operator first, and then all the commands we want to run in pipes afterwards. The assignment actually happens at the very first instance, and then we can call as many functions as we want afterwards. If I piped down and I had like 100 lines of piping stuff down, my assignment would still happen way up at the top. This makes readability really easy, because you know what object was being created by that next 50 or 100 lines just by looking at the first line of code. It's just the way it works. Okay, so I filtered down to the country equals China, and then I got head on the data. If we remember, head is a command that returns, by default, the first 6 elements of some object. But if you give it a number as a second argument, you can tell it exactly how many elements you want returned. I said head 4. It gives me the first 4 observations of this China object, which are the years 1952 through 1967. Okay, that's everything we need to know to get into actually plotting things. Should have had my meme slide here. Okay, so these are the base R plots from last week. This is what they looked like, if you remember. In this case, I just used the base plot command, which is a scatter plot. I said life expectancy by year, so life expectancy on the y-axis, year on the x-axis. I gave it some labels. I modified the point size. I gave it a main title, right? Remember that syntax. You won't have to remember it because we're not going to use it ever again. That's how you do it. GGplot 2 provides a completely alternative system for specifying plots, a uniform structure for generating plots of just about any type. This is an alternative sort of way of doing graphics in R that most people in the universe of R users prefer over base R, but not everybody. And the longer somebody's been in the world of R, the more likely it is they prefer base R graphics. I originally learned base R graphics, and I'm real savvy with them. By the time I got even moderately good with GGplot, I just left them behind entirely, because it is just way better, except for a pretty narrow range of plots. Yeah, so this is part of that tidyverse package I mentioned before. You can load it with library GGplot2. I'm usually going to call it GGplot, but technically it's a GGplot2 package. Don't know why they didn't just overwrite the original one. Anyway, it's based on this idea called the layered grammar of graphics. So this is actually a theoretical paper about visualization if you're interested in what is the origin of sort of the ideas that became GGplot. Yeah. Basically the idea is that we can kind of string a plot together the way we'd string together a sentence with a bunch of verbs and nouns and things and structure it in this uniform way. I like the way it works. Not everybody does. Okay. This is that same plot before, the scatter plot, done in GGplot syntax instead of base R syntax. What I do here is I call a GGplot object. The function is just GGplot. I give it a data set, data equals China. AES is the aesthetics we're going to set in the plot. I just say X equals year, Y equals life expectancy, and then that's the end of that function call. At the end, I do a plus. I say I want to add something to this base layer, which is geom_point. Notice no arguments in it. Geom_point says, okay, take this base layer here, add a scatter plot on top of it. It inherits the aesthetics that were in this original line and makes points on it. It's okay if that's unintuitive. We're going to get a lot of practice with it. It ends up saving you a lot of time and energy, and also makes graphics much more flexible. By default, GGplot isn't much prettier, really, than base R graphics. In fact, it's really ugly if you don't like gray backgrounds like that, but it's very flexible, and you're just going to be able to add things onto it to change the way everything in the plot looks. Okay, here's an example of adding some things on. So, this is the same basic plot code I had before. Notice the first line is actually exactly the same. GGplot, data equals China, X equals year, Y equals life expectancy. But now inside that geom_point column, or geom_point call I have for the layer, I added color equals red, so all the dots are red, size equals 3. The dots are now bigger than they were before. Then I added X label, year, so it's capital Y year, Y label, life expectancy, GG title, life expectancy in China here, and then notice here I have a call for theme black and white. So instead of having this looking like this, with this gray background, Theme black and white does a border around here, gets rid of the gray background, has like thin axis lines like that. It's a theme call. GGplot has themes. Some of them are pretty good by default. Theme black and white is okay. You can add on new themes, which I'm going to talk about later. You can also customize themes or even build your own themes very easily. Okay. Okay. Notice here between this slide and that slide how similar the code is. Look how different the plot looks. Okay. What I've done here is I've drawn an entirely different type of plot, and I've colored the observations by variable. So I have the same basic call at the top, except now I've done color equals continent. Still a geom point. The main thing is I've changed the data to be the entire data set, not just China. Otherwise, everything here is the same. Without me specifying anything else special, it's added a legend for each individual continent. It's labeled them and automatically assigned a color to each one of the continents. This isn't the most useful plot in the world because we have a discrete axis down here, so things are plotted over each other. I'll show you how to fix that in a second. But, yeah. The syntax is pretty straightforward and usually very recyclable from one plot to another if you have vaguely similar plots. Okay? Maybe you want to facet observations by a variable. So if you look here, the first line is exactly the same again. Well, I think I modified, I added a grouping variable. So it's exactly the same except I added group equals country. And then instead of geom point, I have geom line. So instead of drawing a scatter plot, I'm going to draw a line plot.
What's calling the legend? What's bringing that into the game?
Ah, I'm not manually calling the legend at all. The legend is being called by default because I've set color equals continent up here. It figures out, it knows that by default, you're probably not going to know how these colors correspond to some textual data. So by default, it draws a legend. If you don't want the legend, you can turn it off, but it calls it by default. One of the things I like about GGplot 2 is it usually has sensible default behavior for most things. If you want to turn off some of that stuff, it's trivial to turn it off. If you wanted to get rid of the legend, inside of a theme call, you would say legend.position equals none, and it will get rid of it. But yeah, it does it by default. Okay. In this case, I've done something that would be a very complex plot to do in base R. You could probably do it in lattice, but it would be very complex syntax. What I wanted to do is I want to get a plot of life expectancy by year for each continent separately, but each country in that continent gets its own line. It's trivial to do this. All I had to do was say, I want my x-axis to be year, my y-axis to be life expectancy. I say group equals country. Group is how we specify how the points in a line are connected. We say a single country should have all of its dots, essentially in a scatter plot, connected to each other to draw a line. Then I say I want them colored by continent, which is why Africa, Americas, Asia, they each just have one color within them. You could do color by country, but there's a lot of countries. There's like 140 in the data set, so you'd have a lot of colors. Anyway, then I say geom line, because I'm drawing a line plot instead of a scatter plot, that is geom point. Alpha 0.5 says I want to make it 50% transparent, so that if the lines are kind of go over each other, they form like a more saturated location instead of just being solid overlapping lines. If you have a lot of something, I like using transparency so they layer. Then the same X labels, Y labels, and overall title. Okay?
What's the AES after Gapminder?
AES is the aesthetics. I'm going to go into detail on what exactly that does here in a second. That's how you set the way in which variables relate to drawing things on the plot. So AES X equals year says, well, the data are the x-axis for whatever I'm going to plot is going to be the year, so a variable year. Y, whatever's on the y-axis is going to be life expectancy, but then we're going to have some sort of grouped operation. For instance, group automatically with a line draws between all of the points in that within that particular country. Color by continent. These all rely on variable values to determine like how they work, and they will work differently for different sorts of layers. Yeah.
So we loaded GGplot 2, but we're referencing GGplot.
Yeah. So the function is called GGplot. The library is called GGplot 2. That's just the way it is. That's life. Yeah. Yeah. Because I think it was basically the actual second entire package that that Wickham did, but I'm not 100% positive. Or I don't even know if Wickham did the first GGplot package. I should know my history, but I don't. Anyway. Okay, so we've seen a bunch of example plots, so all of you are probably like, none of that makes any sense, this is confusing and weird. That's okay. The point of the grammar graphics is you learn how the plots are structured, how the language of them goes together, and then you can assemble them from the ground up. But if you don't know the language of them, it's kind of gibberish, right? So, GGplots are constructed from two primary components. There are layers. The layers are the actual structural components of a graph. We add layers to a ggplot2 object using the plus sign. You just tack them on like you're adding things on, because you literally are. It's just an addition to the object. Layers include things like the lines, the shapes, the text, of any kind on the plot. Basically, if you can see it, a layer drew it. The second component are the actual aesthetics. The aesthetics determine how these layers look. They don't create the layers, they modify them. They give them some sort of color or shape or something like that different from their default. We set aesthetics using arguments inside of the layer functions. So you generate a layer with a particular function unique to that type of layer. Inside of that layer function, you give it arguments, and those will set the aesthetics that make that layer look a different way. This includes things like the locations of, say, points. So X and Y are locations. They're coordinates. Those are an aesthetic if you map them to a variable. Colors, the sizes of things. Now, aesthetics determine, so you could set an aesthetic directly and say, like, alpha equals 0.5, 50% transparency. I could instead make it so that alpha was dependent, was mapped to a variable. So for instance, if I had a variable that runs from 0 to 100, say the accuracy of an estimate, I could make it so my more accurate estimates are more opaque, and my less accurate estimates are more transparent. That is mapping a variable to an aesthetic. So you can set things or you can map them. We're going to play with this a lot over the course of this term. Okay. There are a lot of different types of layers, and there's packages that add even more layers to ggplot. So common layers we'll encounter, particularly in this class, are the base layer. GGplot just initializes an object. Usually you use it to specify the data you're going to use in the plot, but you can actually just initialize it with GGplot, no arguments at all. It will create an empty framework for a plot. GOmPoint, which we saw before, will create a layer of scatterplot points. GOmLine will create a layer of lines. GGtitle, XLab, YLab do layers with labels on them. Facet wrap and facet grid create those separate individual plots. So just by adding like the command facet wrap here, I could take a single plot and break it up along, for instance, the levels of some character, some nominal variable, some factor. I could break up a single plot into 5, 10, 20, 100 plots with a single function call, just dividing it up by all the categories of that variable. I'm going to do this a bunch for examples. It's okay if it's confusing. The difference between facet wrap and facet grid is that facet wrap, let's say you break it up into 10 different plots. It might display, depending on how wide your document or your plotting surface is, it might do like plot, 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 plot. If there's 10 plots, it just fills them until it runs out of them. Facet grid is, say, if you have two different nominal variables. A common example would be like, I have like self-reported sex here, and then I have something like 3 different locations for a study. Location here, it would be like male, female, location 1, 2, 3, and there'd be a plot for each of the combinations of those factor levels. So if you want to do lots of individual plots of data that have some sort of stratification based on some categorical variable, you just put it in facet, you can generate plots for it. I have a really complex plot that's in an actual paper I have under review right now. I'm going to show at the end to give you an idea of how this really works. It's really neat. Okay. And the syntax for that is very easy. So for instance, if instead of this location on the top, this was an age group, the syntax would look like this. Facet grid gender, well actually you said self-reported sex, but you could do gender by age group, and this would be the y-axis, and this would be the x-axis that it would actually tile all the plots by. So this generates, you know, this times this many individual plots. Then there's things like theme black and white. There's tons of different themes, but what these do, this one in particular will just replace the default background with sort of a black and white one, modify some of your like axes, adds a border and things like that. Some themes do wild changes to your plots. There's actually downloadable themes for like The Economist magazine has a downloadable one. There's a Stata one that makes them look like Stata plots, stuff like that. You name it, there's themes out there to make your plots look like anything. So again, all layers are separated by a plus sign. In most of the syntax I use on here, I try and put each individual call to a different layer on a different line for clarity. Sometimes I'll put ones that take very few arguments, or like one argument, a bunch of them on one line. But normally, you'll end a line with like plus. I go to the next line, add another layer, go to the next line, add another layer. Yeah?
Is there a way to like access a list of the variety of different things that exist, or just do that on the
Yeah, for all the themes. Well, an easy way. Should have had this open. Oh, this is the part where I wonder if the computer actually has GGplot 2 installed on it at the moment. Because these things always feel like having nothing useful on them for me. So let's see. Of course not. Okay. You do that in the background while I lecture. Okay. So, basically, if you want to look at all the themes, you could look in the index, like the help file index, for them. What I would normally do is I would probably Google list of GGplot2 themes, and it's probably going to be able to find somewhere that actually has pictures of all of them. 98% of the time, if I want to know how to do something that doesn't immediately come to mind, I just Google it, because somebody else has already put together a nice little presentation on the topic, probably. Yeah. I really only use about 3 different themes with any regularity. I use theme black and white, theme minimal, and theme classic. About the only ones I really use. There's a few others. Yeah. Okay. Second main component of GGplots are the aesthetics. So the aesthetics control the appearance of all the different layers you use in the plot. Things like X and Y will be the X and Y coordinates, which makes sense. There's some 3D plots that will also have a Z. There's color, which will set the color of different elements based on some value in your data, or fix it to one value if you just give it one. Group will describe, say, which points are, for some, based on some concept, some variable grouped together. It's very commonly used with lines. Size will make the points or the lines bigger or smaller, depending on some set value or on some variable. And alpha sets transparency. There's a lot of other aesthetics. Every single layer has a different set of aesthetics that work for it. Pretty much every layer, almost every layer will take like X, Y, color, and probably group, but other ones may be more or less common. Okay, so layers can take arguments to control their appearance, that is, their aesthetics, such as the point and line colors or transparency, but there's 2 different ways you can set things. There is setting and there is mapping. Okay, so arguments like color, size, line type, all the ones I show up there, can be used directly on the layers. That is not inside the AES function, like this. I could say geonPoint color equals red. That makes every dot drawn by that layer red. This is referred to as setting an aesthetic. If something is set, you're fixing it like this, and that value, that color, does not depend on your data in any way. No matter what data you give it, those dots are always going to be red. Right? Arguments you put inside the AES function inside something will depend on the data. These are referred to as mapped or mapping aesthetics. If I say geonPoint AES color equals continent, it's going to assign a different color for those points for every value of continent. So any point that's in Africa is going to have one color. Any point in the Americas is going to have a different color. That obviously depends on the data. We haven't manually set it. Therefore, it is mapped to a variable. So, AES in the GGplot layer, the overall GGplot layer, the thing you initiate the plot with, will set all of the aesthetics you set in it for every subsequent layer unless you overwrite them. Yes?
Then data outlier will be colored in different colors.
Oh yeah, you could absolutely. So there, if you could figure out of a way to define an outlier in your data. So for instance, you could do something like you could say you ran a regression model and you extract the residuals, and you did say anything that had a studentized residual over 2. You said that is a outlier. You could make that a variable in your data set that just takes the value of like red if it's an outlier, map it to color, and it will make it red whenever it's an outlier in the data. So the answer is yes, and it's easy. Does that make sense?
Yeah, you decide the boundaries first, then you put the
Yeah.
layout of the settings.
Yeah, so what you would do is, with most things in GGplot, you don't modify the data in any way inside of the GGplot. You do all the data modification, which would include generating a column that would say this is an outlier and this is not. You do that before the GGplot. So you do it in, like, you'd mutate it or whatever using DeepLiar, generate it, you'd run the models, and then send that to the GGplot. You wouldn't make it determine which ones are outliers on its own. There are some functions in GGplot that can do that, but general good R style would be doing that ahead of time and then plotting it.
So different plot in different layouts.
Well, it more like you determine the outlier by running a model before you ran the plot, and then making a column in your data that is yes, like true if this is an outlier and false if it's not, and just highlight things when they're true. Does that make sense?
This is different data set.
Yeah, you'd be modifying the data. Yeah. So you could do it all in one data set, but you would just add a new column to it or something. So normally for like regression output, basically I'll cover a lot of that in week 10 or 11 when I do model results, and I'll show about that. Yeah. Or if you come to the lab, I can help you out and give you very specific ways to do that if you're interested. Okay. Okay. So like I was saying, if you set things in the aesthetics in the base GGplot layer, it will affect every layer you attach to that base one. You could overwrite that in individual layers, but this sort of forms the basis for all of them. This is nice if you have like 3 or 4 layers that you all want to have uniform colors, uniform like X and Y coordinates and everything, which is why on that original plot I did way back, I had a geom_point call that didn't have any arguments in it at all, because I'd set the X and the Y values in the original GGplot call. Does that make sense? They just propagate. Okay, so all the language in this slide is very specific, and you might be like, this is really pedantic, but it makes Googling for answers a lot easier. So if you know that you want to set something versus map something, you know the exact terms to use to Google it. Normally you're trying to figure out clever ways to map your data to something, so you can be like, mapping aesthetic, insert thing I want to do, and then good Stack Overflow results will appear. Precise Googling is the secret to stealing good code. Okay. So, we can store GGplots like we store any other object in R. We take the entire GGplot call, that is GGplot, but then all of the layers we add to it with pluses, and then way up at the top, like we did with pipes, we do the assignment up here. So if I want some plot that is life expectancy by year, my entire Gapminder data set, X is year, Y is life expectancy, colored by continent, all these aesthetics set, I could save it to this object, life expectancy by year. When you do this, the graph is not going to display. It's going to write it to an object, but it's not going to plot it out in your little viewer. It's just going to store it. Okay? The neat thing here is that now, if you do want to display this plot, you can just type in or run this individual object, and it will display the plot. But another cool thing you could do is you could use this object name and keep adding more layers to it after you save this object. For instance, I can run life expectancy by year just by calling on it. It produces this plot. Or I could take life expectancy by year and then add a geom_line layer to it where I said group by country. Now each country has its own line running through all of those dots. I didn't have to redo the entire GGplot because I could just save the individual object. This is something that is completely impossible with base R graphics and is really easy to do with GGplot stuff. Sometimes I'll have a whole bunch of plots in a report or something. They all have the same base, and all I'm doing is modifying like one of the layers or applying a couple layers to it. It saves me from retyping all of my themes and everything. In the homework in week 7, you guys are going to write functions that will allow you to like automatically generate GGplots with set themes and stuff using like one command line. It's going to be cool stuff. So we're all building toward things. Yeah, so that's kind of neat. This is a much more useful plot, still hard to read than this plot, but it's more useful. You have the obvious information that you see clustering of colors in certain ranges, right? It's more useful. It's still a hideous plot, objectively speaking, but we'll make something out of this. We'll make it less useless and hideous. Okay, so here's some take-read suggestions. If this wasn't one of those lectures that I'm already running rapidly through, I'd say we'll sit and play with it for a bit. But these are sort of things you might want to mess with. I recommend looking back at this stuff when it comes to doing your ggplot homework for this week. Things you might want to do, like you could filter your data set down to individual rows so you can plot different specific countries, years, something like that. You might try entirely different layers that I'm not actually going to show in this lecture. Things like geom histogram does histograms. Geom density does density plots of continuous variables. There's box plots for people familiar with box plots. I am going to do a couple examples of this. You might use something like geom smooth. Geom smooth will draw a regression line through data or a low S curve through things. So if you want to see, like, fit a line through the middle of a bunch of points of data, geom smooth does that. Something else you might add if you're interested, Jeff Arnold, who up until recently was here at the University of Washington, has a package called GG themes. You could click to this link that has GGplot themes that will theme your graphics to look like the graphics that are in certain publications or other pieces of software. Like you might want your plots to look like the default theme in The Economist, the magazine. You might want to look like Stata if you're wrong and bad. You might want them to look like Excel plots. Yeah, so you can do that instead of theme black and white. Okay? If you look around, there's lots of other themes and theme packages. One of my favorites is Cowplot, which adds some more things than just themes, but there's a bunch out there. I think I even linked some on the website. Okay, so here's a nice little thing, a trick that is probably going to be useful to only a few people in the room, but it's important that people know you can do this sort of thing. So sometimes you want to do a scatter plot of things that have discrete units. Well, the problem is if everything has a discrete unit, all of the dots are going to be right on top of each other because all those observations have the exact same coordinates, right? Every single observation in Africa in 1972 is exactly at this point in the data. If I have year here and I have, like, my continents over here. So we don't know if this dot represents one country or if this dot represents 50 countries, right? This is called overplotting. It's really common if you have discrete units. We can fix overplotting with jitter commands. So if I add inside of geom point the argument position equals this function, position jitter, I can specify to randomly distribute the dots left and right by a certain amount and up and down by a certain amount in the units of the axes, the x-axis and the y-axis. So the units down here on continent, this is just a unit of 1 between Africa and the Americas. So I've jittered it 0.5 so that they will come up to halfway away from the center point and no further so they don't overlap. And then I've done 2 years up and down because the data are separated, what, like 5 or 6 years, something like that. Yeah, so it just randomly shifts them out. What we can see immediately here is that there are a lot more African countries than there are, like, countries in the Americas, and way more than out here in the Pacific, right? Jittering. Sometimes it's useful, sometimes it's not, but just know that you can even do things like adjust positions of things using, like, little adjustment functions and stuff. Maybe it'll give you some ideas for how to do cool things with your plots, especially in these data sets.
Is it kind of creating new plots, so it's like sensitivity analysis? That's kind of what it's randomly creating more plots? Or
Well, no, what it's doing, it's not creating more dots or anything. These are the data here, but the problem is that before, every single, like, observation was just, like, all of these observations in a rectangle here just happen to all be on top of each other. So all it's done is it's added random noise in the locations. So every single one of these locations has a random amount added to or removed to its X location and a random amount added to its Y location added or removed. So it's just taking all those dots and spreading them out in a random fashion. It's just random noise. The only purpose of that is to make it easier to see how many dots there are. No additional information is being conveyed. And if used improperly, you're actually making it harder to understand what's going on. So use that sort of thing carefully. People often do like jittered things, and you see it a lot in if you're working with, say, results from discrete models in a statistics journal, they'll often jitter things so that it's clearer that there's certain densities of observations and things. Okay. Okay. Other things you might want to do. You might want to modify the axes of your plots, say change what the scale they are, change the units of them. If you just want to change the range, you can use the layers xlim or ylim. You just give them some numbers and they'll increase or decrease the range of the y-axis or the x-axis. Maybe you want to do something like a transformation. These are layers. You can add a layer for, I want my scale, my x-axis to be in a logarithmic scale, like a log 10 scale, maybe a square root scale. So if you have something that has a lot of skew to it, you might want to log it. So maybe it's like, linear in its log, or if it's normally distributed in a log, you might want to give it a logarithm transformation. I'll show you what that looks like in a second. You can also do things like change where the breaks are on something. So if you have like some ugly tick values on the side of your plot, you can move them to your heart's content and display something specific. So for instance, maybe what I want is I want a logarithmic scale to something. In this case, I've taken that China data I created before. My y-axis is GDP per capita. This is something that makes a lot of sense to log because GDP, in China, took off a lot. So I want to compress it a little bit. All I did here is I did sort of a similar plot before. X is year, in this case Y is GDP per capita. I've done a line plot. Notice no additional arguments here. The only thing I'm plotting is one country, one line. Takes care of it for me. But then I say scale Y log 10, and I said breaks at 1,000, 2,000, 3, 4, and 5. So 1,000, 2,000, 3, 4, 5. So the scale is still logarithmic, but the numbers are appropriately located for where they are based on logarithmic transformation. Makes using log scales really, really easy and setting the breaks for them. This is great for people who deal with variables that are sort of distributed log normally. I also manually set the X limit to 1940 to 2010, which is outside the bounds of the data, and manually set the GG title to it. Does that make sense what's going on there? Pretty straightforward. Okay. Yes?
If you wanted like the title to be centered, how would you do that?
Comma h just equals 0.5. Yeah, it's just a setting aesthetic inside of the GG title. So the way justification works, h just is horizontal justification, v just is vertical justification. 0 is left justified, 1 is right justified, 0.5 is center justified. So it's proportional. And the reason I know that is because I justify things a lot, not because there's any secret to it. Yeah.
Are we gonna get to, like, let's say we wanna plot two different sets of data on one plot?
Okay.
And then you have like primary data, where you
Yeah.
actually know what the graph is, then you have a predictive model past a certain point.
Oh, yeah. So that's... Be careful with the difference between saying two different data sets, and that's not really two data sets. That would be, for instance, extrapolating on one data set, but I would think of that as being one data set. GGplot does not play well with putting multiple unrelated data sets on each other, but data sets that have like the same measures or extrapolations are very easy to do in GGplot. Hadley Wickham is actually, who creates GGplot, is philosophically against putting two unrelated data sets on the same plot or even next to each other, so it's nearly impossible to do in GGplot. But there's ways to work around it. Something like that, extrapolation. I'm not going to cover anything about extrapolation because I don't do anything with models. But the answer is yes, it's very easy to add. And the way to do that is essentially add additional rows to your data set, but then have some flag variable so that you have some variable that takes a value of 0 for normal data and takes a value of 1 if it's extrapolated data, and then color code by it. So your extrapolated stuff would be color-coded, and maybe only the extrapolated things have a confidence interval on them of some kind, and the other data doesn't because it's actually observed. Very easy to do. Okay. Great question. Okay. Maybe in the previous plot you felt like the fonts were too small. If you want to change globally all of the fonts on all of the axes in the title, inside of your theme call like this, do base size equals some different number. 20 is larger than the default. I forget what the default is. It just makes all the text bigger. It's good for kind of scaling it if you want to look a particular way in some memo or something like that. Yes?
When you say like global, is that like still in the same graph, or is that like a graph?
So, sorry.
You said like it'll change the text globally. Is that
Yeah, within the graph. Yeah. All I mean by globally is that it does this text, this text, this text, this text, and this text, and a subtitle if it was there, and any additional axes. But it's definitely within the individual graph. Yeah, great question. Yeah, you don't. That's another thing. Base R graphics, a lot of the settings you set are actually global within the entire environment, and that just fucks stuff up all the time. You'll be like setting parameters, and it just propagates to all the other graphs, and it's a nightmare. GGplot's all self-contained. Yeah.
What about on the y-axis? So the label is life expect.
Yeah.
Is that after the y equals? Is that an actual like variable, or is that a label?
This?
Yeah.
That's the actual variable inside the data set.
What if you
China.
want to say, instead of having just the variable name, because sometimes those are kind of funky, and you want to actually say life expectancy on the y-axis, how would you do that?
So you would do plus y lab, just y
Yeah,
lab,
do the Y
and then
lab.
quotes and say life expectancy, type it out. That, or change the variable name itself. And I'll talk about sometimes you can get spaces in variable names if you know how to do it. Sometimes I like to work with nice variable names so they have like spaces and proper capitalization in the data frame because I'm too lazy to specify my labels manually. Programming is all about being like constructively lazy in the right way, so you do as little work as possible, and that can be stuff like that. Okay, so lots of little adjustments you can make to plots with regard to things like texts and ticks on the side. So the ticks are both the sort of little lines sticking out here and the location of this number. That's the tick on the axis. Anyway, so if you want to make adjustments to those things, you can mess with them in the theme layer. So the theme layer, I will note, theme here is not the same layer as this. I have no idea why they decided on this like inconsistency between these. So theme black and white sets the way the plot looks globally. That means all the elements of the plot. Theme is for manually setting individual elements of how the plot looks. I recommend doing like theme black and white and then afterwards do a theme call and modify things, because this will overwrite things you set in this. It's just a GGplot peculiarity. So inside of a theme layer, you could do things like plot.title equals element text. This is just a way of saying your plot.title is going to set some sort of individual arguments that are based around the fact that it is a text element. For instance, you might say size relative to. This will just make the title of the plot twice as large as the default. And if you adjust all of the sizes of everything in the plot, it will continue to be twice as large as it would normally be. Relative sizing. HJustify will justify it to the left, I believe. If I did HJust 0.5 there, it would be in the center. X-axis text X, element text angle 45 will rotate your X labels 45 degrees. I rotate my X labels a lot because very often I have some sort of axis like a year or something that's a lot of text there. If there's a bunch of them closely stuck together, they overlap. If you write them 45 degrees like that, well, to you guys, they will all nest in next to each other nicely. I think I have an example in a minute. It's a common one. Maybe for some weird reason you want to change your axis text to a different color. Maybe you're doing a presentation that doesn't have a white background, so you want to change it to be a contrasting color. You can make the X and Y axis labels blue, for instance. You could make those axis ticks longer, the little lines that stick out, or shorter if you're really anal about how things look. This is something I do all the time because I am. Yeah, then as I said before, put your theme call after like a theme gray, theme black and white, or something like that. If you want to know everything you can change inside a theme, you can look in like the GGplot 2 documentation or look on like the graphics cookbook or something online. There is a tremendous number of things you can modify inside theme. Basically every little element of a plot. Tons of stuff you can mess with. Try not to get lost in it forever, which I do. I've wasted many hours of my life doing this stuff because I want to look exactly right. You'll see the result of that in a minute. But yeah, lots of options. Okay, so if you want to control the colors of, say, like a continuous range of things, like you want to fade something based on values from like across a gradient, you can do things like that using stuff called scales. Scales are layers that you add to your plot that will control how some mapped aesthetic appears. So you can do things with, say, color. You do something like scale color continuous would allow you to set a color along the ranges of a continuous variable. But you can also do things like scale shape manual, which would mean that different values of a variable in your data each have a different shape, and you've manually set which shape corresponds to which value in your data. This is kind of complex, and you'll probably get experience just by messing with it, which is why I require in your homework that you have one manually generated scale. Yeah, some examples of things you might want to do. Scale line type manual. That will manually specify the line type for each value in your data. Scale alpha continuous will vary the transparency over some continuous variable. This is what I was talking about if you have, say, a whole bunch of estimates in your data, but you want to make it so that the estimates that are reliable are opaque and the really unreliable ones are transparent. You could have a column in your data that is the reliability of that estimate, and they just would fade in or out based on that reliability. I've seen some people do that in papers for simulating data and things. Another thing you might do is set some sort of specific color palette. Scale color brewer palette equals spectral. We'll use the spectral palette built into the color brewer package to generate a pretty color palette based on the values of some variable. This is something you might want to do if, again, you're really anal about how things look, so I do this all the time. Let's say you have some consistent colored theme, say, in your slides you use to present the class, like that. You might have some brewer of palette of colors that you use that complement your slides perfectly. You do it like this. You'd set it. If you're interested in this, look up the color brewer package for R, maybe mess in the documentation. I don't go into in depth, but just know that there's a lot of really complex options for setting scales that are really cool. When confused, Google or Stack Overflow it, or Slack channel me or email me, something like that. I love it when people bring weird problems around scales because they can be really complicated. We'll figure it out. Okay, so here's an example of something you might want to do. Let's do manual naming of a legend and manual colors for this plot. So this is the same life expectancy by year ugly useless plot from before, but now I've added to it a scale color manual call. Inside of a scale, the name argument is the name of the legend that appears over here. What I wanted to do here was I wanted to have a long, useless legend title as an example. I wanted to say, which continent are we looking at? See what I do up here. Which /n continent /n are we /n looking at? /n is the line break character. It works inside of any kind of text element that appears in a GGplot. So it just means that which continent are we and looking at are all on separate lines in my legend title. If you have something really long that's going to run off the plot, line break it, use /n's. Okay? Then I've manually set the colors over here. I've said the values for the scale color manual, any data point in the data set that has a value of for a value in continent of Africa is going to be sea green. So this Africa color right here is kind of hard to see, is sea green. Americas are turquoise. Asia is royal blue. Europe is violet red 1. And I actually I'm dumb. How do people usually pronounce that? What do people? Oceania. Yeah, people always say that. It's not fucking spelled that way. Sorry. Anyway, that drives me insane. But anyway, yellow. So it's yellow over there. Manual scale colors. Pretty easy? Okay. You'll end up playing with this in your homework a little bit. Okay. So here's an example of going way over the top to make a plot with fussy manual legends. So this is based on, well, it's the Gapminder data. It's life expectancy by year. I've grouped it by country to do a line plot. I've done a lot of crazy stuff in here. So the first thing that I've highlighted up here, it might be kind of hard to see the highlights. I need to change that to a lighter background. But anyway, is I did this thing, geomline, stat equals smooth, method equals low s. Low s is a type of smoother, kind of like a regression line. It's actually based on splines, and it follows through the middle of the data. This is going to draw a low s curve line of best fit through my data points. You'll see what that looks like in a minute. I facet wrapped this plot, so it's going to have this tilde continent, means I'm going to have a different plot for each continent in my data. Okay? Then I have a scale color manual. The name of the scale is the life expectancy for different countries. You'd think, not exactly. Instead, the values are going to be country equals black, continent equals Dodger blue. So that means in this plot, countries are going to have a black line, the continents are going to have a blue line, because I'm doing a low S line for the continents through the middle of all of my countries. You'll see what this looks like in a minute. Then I've tweaked my legend to put it out of the way, down and right, and I've done that axis text x element angle equals 45 to get 45-degree angles. There's a lot of other junk going on in here. If you're interested, you can look back and try and figure out how it links to this plot. So that generates this plot. Life expectancy in every country in the data set, 1950 to 2007. I've added a subtitle. You see in GG title, I have the main title, and then subtitle, equals by continent and country. It's driving me insane. By continent and country. Every continent has its own plot because I facet it, facet wrap by continent. My legend over here says life expectancy for continent has this wide blue line. That's the low S smoother going through the middle of all of the data points for all the countries within that continent. And each country is its own little black semi-transparent line. My x-axis ticks are rotated 45 degrees because if I didn't, they'd overlap in the middle. Okay? Something interesting you'll see immediately here that I've plotted all the data in this way, there are some odd things going on. Do people know what could possibly have been happening in this time period? So this is about the mid-early 90s in one country in Africa and the mid-late 70s in one country in Asia. People know your history?
The Rwandan genocide in Africa in the 1990s and the Khmer Rouge genocide.
You're on
in
fire!
the 70s.
Exactly. We have just used our Gapminder data to locate the two most severe genocide incidents in the world in the period between 1950 and 2002. Massive dips in life expectancy are usually due to genocide, if they only happen in one country. If they happen in all the countries, like in Africa, that's the AIDS epidemic. Right there. Demography. Science. Okay. Cool. So, if you want to know more about customizing legends on a plot, the R Cookbook website is really good, has a lot of information, and the neat thing is it's sort of based around examples of things, showing you the actual plots and then the code associated with it to generate it. All good programmers steal code because someone else has already solved your problem. Look for people who have already done what you're attempting to do if you can't figure out how to do it. It's perfectly fine. I recommend doing that. Or Slack channel, email list, something. Okay. Next, maybe you want to save your GGplots. And by save them, I mean maybe you just want to produce an image file that you could embed in a document, or because, you know, journals live in the Stone Age, they want them saved as separate, like, image files, usually in some weird, terrible format, and attached in a completely separate way to the document, something like that, and they never put them where you asked them to put them in the article. Not that I'm bitter about that right now. But, yeah, so let's say I want to save some image I've created with GGplot, some object, as a ping or a PDF file. There's a command in GGplot called ggsave. You just say ggsave. You give it a file name you want to save. By default, it's going to save in your working directory. If you want to say save it in a, I usually use a directory inside of my projects called img for image. You would say like ./image/ a file name, and it will save it relative to your current location there. You'll notice here I say ggsave, I saved a file .pdf. I gave it that life expectancy plot. I didn't have to tell it I want to save it as a PDF. It parses out this text and sees .pdf is like, oh, it's right as a PDF image. It supports that for PDF, PNG, JPEG, SVG. For anything online, I highly recommend SVG files, which are scalable vector graphics. You can zoom in infinitely and they will look good no matter how much you zoom in, because they're vector graphics. You could set the height of it, the width of it, what units you want those height and width to be in. If you don't give it any of these arguments like height, width, it'll try and figure out an ideal sort of scaling of everything to save. Usually it works pretty well. The more complex the plot, the less likely it's going to be pretty. Sometimes you've got to save it a few times and tweak stuff. Yeah. If you just need to send a quick email, like with a plot in it to somebody else, I actually think it's perfectly fine to do the bad, non-producible way, which is to open up the plot in the little window, viewer window on the bottom right of our studio, scale the window until it looks good and then screenshot it and send it to people because I'm really lazy, and if I'm only going to use that plot once, that works just fine. It's not reproducible though. Don't tell people I tell you to do that. Anyway, okay. So, just yesterday I decided I would add in a bonus plot because I want to show that you can actually make complex publication-ready graphics in GGplot without like breaking yourself writing huge amounts of code. So this is the complete syntax. I mean, this is every bit of syntax involved in the generation of the graphic for a plot in a recent journal article that I sent in on R&R to the journal City and Community here with a couple of my co-authors. So this plot has a fairly large number of layers. You're going to see why in a second. But I'm just going to run through the code. Basically, I have a data frame that is a bunch of estimated point estimates. These are predicted probabilities from some logistic regression models I've run. It's not important that you know what that is, but basically just know it's a bunch of probabilities. I just want to plot basically some expectations from a model. This is where we would expect people of a certain type in a certain type of criminal incident. This is the outcome we would expect for them. This plot I'm going to show you is the predicted likelihood of arrest for people by their race, the type of neighborhood, the race of the person who called the police on them. Because I have these data where I know the race of everyone who called the police on everyone in Seattle in a certain time period, and I've been working with those data for a while. Anyway, so I'm saying I'm going to create a GGplot with these data. My x-axis is going to be the target. The target is whoever the police were called on. That is the race of them. Y is a point estimate of the probability. The group is the race of the reporter. So that is, was it a white person who called the cops? Was it a black person who called the cops? I'm then going to facet these data in a grid by the type of crime, that being serious crimes versus nuisance, like public order crimes, and also by the type of neighborhood. So we used a multivariate weighted class mixture model to classify gentrification in Seattle, 3 different types of neighborhood, essentially 2 non-gentrifying ones and then 1 gentrifying type of neighborhood. Science, don't worry about it. I've added on error bars, because these probabilities are estimates. So the error bars just create sort of a vertical confidence interval in every estimate. I've created geom points that are a point for the point estimate of that probability. I have filled them based on the reporter, so that if the reporter is white, the dot is white. If the reporter is black, the dot is black, so people can read it. I have manual filled scales here. So for the reporter, if it is a white reporter, it's white. If it's black, they're black, like I said. I have titles, subtitles, XLab, YLab. I've modified, see, I'm just using theme black and white like I showed before. The only thing I've modified is the location of the legend and removed the background color of the legend. So I'm using almost entirely default looks on this plot, and it comes out looking like this. Okay? There is a butt-ton of information in this plot, but GGplot handled it with grace, displaying a lot of things at once. So this plot is probability of arrest by the race of the reporter, the race of the person the police were called on, the type of neighborhood, that is changing disadvantaged or stable white neighborhoods, the type of crime, which is serious crime versus nuisance crime. Reporters are black reporter, white reporter. The people who the police were called on are either white or black. So race of target down here and probability on the left. So if you're curious about any particular scenario, like I want to know what happens if you're in a stable white neighborhood, you're a black person, a white person calls the police on you for a nuisance crime, you are right there. You are really fucking likely to get arrested in Seattle. So, GGplot works for publication-ready graphics. It's very good at it. That is not very much code. If I wanted to generate that in base R graphics, I would be spending hours and hours trying to make a plot that looks like this. I then could produce using that code by saving that code and removing just actually, I didn't even have to change anything in that plot. I produced 3 more plots in the same article without even generating this code again. All I did is change which data set I sent to it, and it generates all the rest of the plots for the article. It's useful. You can use it in real life. It just takes a little time to master. It can produce pretty things. Any questions? Science. Okay. Your homework. Your homework is, again, another vague homework meant to make you play with things until you get tired of playing with the homework, is to pick some relationship to look at in the Gapminder data. You're free to do whatever you want, as complex or as simple as you want. write up an RMD file that investigates it graphically. You might do something like mess with some particular subset of data, like just Africa, just a range of years. I would recommend doing multiple things. Upload again the RMD and the HTML file. I'd like 4 to 8 plots. However many you're comfortable with. More is fine. Don't spend way too much time on it. I would like all titles, axes, and legends to be labeled clearly. That is no raw variable names, unless you get clever and rename the variables to be nicely formatted. You can do that if you want. Go for it. I want at least one graph using facet wrap or facet grid, because faceting is one of the most powerful things in GGplot, and you should learn how to use it. At least one manually specified legend. It can be quite simple if you want. Just specify one. By manually specified legend, I just mean scale manual something. And they do it manually. You can use any geometries you want, like histograms, bar charts, vertical, horizontal lines. If you want to know all the different geometries you might use that are sort of built in GGplot 2, click on this link. It's a data visualization cheat from our studio, and kind of lists most of the core functionality in GGplot. Make it pleasant to look at, hide your code, any write-up observations in words as well as on the graphs. You don't have to like make big statements, just be like, I have plotted, this is a plot of this and this, it goes up over time or something, right? Interpret a little bit. Use chunk options like echo and results to limit your output. Submit the RMD and the HTML. That's it. Wow, we got done fast today. Questions?
When do we have to do the peer?
The peer review?
Yeah, when do you do
It's due at the same time as the homework next week.
Okay.
So you got 1 full week on. Question?
That's it.
Ah! Two birds, one
Do you
stone.
have to leave the comment to finish the peer review? Does that include like a score or? is
Yeah,
peer
oh,
review
yeah,
50%
so-
rating? Like what's that?
Best question, yes. So what you do is you're going to leave a comment, between 2, 3, 4, 5 sentences on it, and then at the end, just say like 3 out of 3, 2 out of 3, 1 out of 3, 0 out of 3 if they didn't turn anything in. So you just put a numeric grade at the end of the comment, and then I go through every single one of the homeworks. I read it. Basically, if I encounter... Well, actually, no, I look at every single one of the homeworks. I kind of glance at them and be like, if somebody gives like a 3 out of 3, but I look over there and it doesn't even load on my canvas, I know it's full of shit, and so I'm going to fix that. But, yeah, leave a little numeric score. 98% of the time, that numeric score is what the person's going to get. Sometimes I bump the grades up if I think somebody's a little too harsh. That's about it. I'm real easy. I don't want anybody to fail in this class.
So when this just backs up our markdown, but like when you publish that, your computer has already taken care of all the coding, all the processing power, right? So if HTML was fine on your computer, it should theoretically maybe look fine on someone else's computer.
Yeah, in the markdown documents you guys make, absolutely.
Okay.
Yeah, because the HTML document, everything's already been run. It's not the case necessarily for my slides here. My slides, you might find cases, and let me know if this happens, where my slides render a little bit weird on your computer. If you don't have an internet connection, my slides won't even render at all, because my slides aren't knit. They're actually rendered as you load them, but that's a little bit different from what you guys are doing. It should be fine.
Okay, and then my final question, sorry, is just, so when I try to run the code from like the week 2 GGplot RC that you have to like follow along in class, it's like error that it says like I don't have
Sheringan.
Sheringer Beamer. So when I try to install it, it says like R is too up to date or something like that. I just don't understand that error.
Yeah.
Probably not the only one.
So that is because Sheringan Themer cannot be downloaded from CRAN. Sheringan Themer is off of somebody's GitHub. So if you want to compile my slides that are in here, I got all sorts of weird stuff going on in these. So if you're interested, you can come up here and I'll show you how to install the stuff I'm using. I got some weird stuff going on inside these slides. Yeah.
Yeah, I was just trying to like edit the plots slightly.
Oh yeah, I would recommend copying the code out and put it into like an R script file, because Sheringan, which makes these beautiful slides that I love dearly, is actually rather bizarre what's going on underneath. It's a dynamic HTML rendering engine that's mixing cascading style sheets with like R code, dynamically generated when you open them in the browser. It's like, it's gorgeous for slides, but it's going to be gibberish to most people. Yeah.
How do you, I want to keep stealing all your good coding, so for the What's the best way to keep these slides? I mean, because they're all
Keep 'em?
HTML. Should I just
Save the HTML file.
just keep them as HTML files?
Yeah.
Just keep it in a folder.
Yeah, like I said, you could save the raw HTML file itself, open it, and as long as you have an internet connection, it will work.
It'll work.
If you do not have an internet connection, a lot of things won't render. In fact, it won't even load fonts, because the fonts in here are actually being downloaded from Google dynamically when you load the slides. So they break if you do them offline.
Thanks.
There was one over here, and then I'll get...
No.
Oh, you...
Yeah, so, for the geomes, can you make like 3D?
Yes, yeah, there are three-dimensional geoms. I haven't really seriously used any of them. I know they're out there, and there's also like animated 3D geometries. You can do things like interface with the Plotly package to do 3D interactive graphics and stuff. I actually don't have very much experience with that at all. So your best bet is like Googling it, and if you run into problems, asking me and see if I can crack the problems that you have. Yeah, happy to help with it. I just don't have any experience with it. I'm kind of old school. I do mostly two-dimensional stuff because I go to journals where they're not going to let me have online supplements and pretty graphics, and they want everything black and white because even an online article apparently can't be in color. Anyway, yeah. So I'll help those if you run into any problems. Okay.
I've run into a problem when I'm doing our markdown. If I save file, it turns it all to a certificate. It's not no longer in our markdown, and I can't use it anymore.
That's interesting. Are there any other questions? Because I'll help you as soon as I'm done with any kind of questions. Nope. Good. Okay. Get out of here.